Hi guys, welcome back to my YouTube channel. I am Esalidri Manne. Today we are going to learn a very important topic from data structures called expression tree. This topic is extremely important not only for your exams but also for understanding how expressions are actually proceed inside the computer. In this lesson, we will understand what an expression tree is, why it is used and how it helps in evaluating expressions correctly. We will also see how tree traversals like inorder, preorder and postorder are connected to infix, prefix and postfix expressions. By the end of this lesson, you will clearly understand how expression tree work and why they are so important in programming and compilers. So let's get started. Before we talk about expression trees, we must clearly understand what an expression is. In simple terms, an expression is something that gives us a result. It is formed using operands and operators. Operands are values like numbers or variables. Operators are symbols that perform actions on operands, such as plus, minus, multiply and divide. For an example, in this expression 2 plus 3, the numbers 2 and 3 are operands and the plus sign is the operator. Now let's come to the main topic, expression tree. An expression tree is a special type of binary tree that is used to represent expressions. In an expression tree, operators are always stored in the internal nodes while operands are stored in leaf nodes. This rule never changes, so please remember it well. Why a binary tree? Because most operators works on two operands like left operand and right operand. That's why each operator node has at most two children. Think of an expression tree like a step-by-step instruction list. Just like cooking follows step in order, expression tree shows us which operation must happen first and which must happen later. Now let's talk about the purpose of expression tree. In other words, why we actually use expression trees. The first purpose is clear expression representation. When expressions become long or complex, it is hard to understand the order of operations just by looking at them. An expression tree shows the structure of the expression very clearly using nodes and branches. The second purpose is easy evaluation. Using an expression tree, we can evaluate expressions step by step in a systematic way. By applying postorder traversal, the computer knows exactly which operation to perform first and which one to perform next. The third purpose is conversion between prefix, infix and postfix expressions. This is one of the most important uses of expression trees. Let's now construct an expression tree for a very simple expression 2 plus 3. Here, the operator plus becomes the root node of the tree. The operands 2 and 3 become the left and right child nodes. Whenever you build an expression tree, always look for the main operator first. That operator becomes the root. If you understand this simple example clearly, complex expressions will also become easy. Now let's look at a slightly complex example. Because of the brackets, 2 plus 3 must be evaluated first. So the plus operator forms a subtree and the multiplication operator becomes the root of the entire tree. This tree visually shows us operator precedence, which is sometimes confusing when we only look at the expression. Now comes one of the most important parts of expression tree traversals. Traversals tell us how we visit the nodes of the tree. There are 3 traversals that you must remember. Inorder traversal. In inorder traversal, we visit left child, then root, then right child. This traversal gives us the infix expression, which looks like the normal expression we write as a human. Preorder traversal. In preorder traversal, we visit root first, then the left child and the right child. This gives us the prefix expression, where the operators comes before the operands. Postorder traversal. In postorder traversal, we visit left child, then right child, and the finally root. This gives us the postfix expression, which is extremely important for evaluation. Now let's understand tree traversals using this binary tree shown on the screen. Here, 1 is the root node. It has 2 children. Left child 2, right child 3. Node 2 further has left child 4, right child 5. Node 3 further has left child 6, right child 7. So this is a complete binary tree, and we will now apply 3 types of traversals on it. Inorder traversal. In inorder traversal, we always follow this order: left child, root, right child. Let's apply this rule step by step. We start from the root node 1, but first we go its left subtree. From node 2, go to left child 4. Node 4 has no children, so we visit 4. Then we visit its parent 2. Then we go to the right side 5. So from the left subtree we get 4 to 5. Now we come back to the root and visit 1. Next we go to the right subtree of root node 3. Visit left child 6, visit parent 3, visit right child 7. So from the right subtree we get 6, 3, 7. Now combine everything. Then we got 4, 2, 5, 1, 6, 3 and 7. Now let's move to preorder traversal. The role of preorder is root, left child and then right child. So the first thing we do is visit the root node. We start with 1. Then we go to the left subtree. Visit 2, visit left side 4, visit right side 5. So left subtree gives 2, 4, 5. Then we go to the right subtree, visit 3, visit left child 6, visit right child 7. So right subtree gives 3, 6, 7. Now combine everything. Then we got 1, 2, 4, 5, 3, 6, 7. Finally, let's look at postorder traversal, which is very important for expression evaluation. The rule is left child, right child and then root. We start from the left subtree of node 1. From node 2, visit left child 4, visit right child 5, visit parent 2. Now move to right subtree of node 3. Visit left child 6, visit right child 7, visit parent 3. So right subtree gives 6, 7, 3. Finally, we visit the root number 1. Now combine everything. Then we got 4, 5, 2, 6, 7, 3, 1. To remember traversals easily, in order we go like left, root and right. In preorder we go like root, left and right. And finally in postorder we go like left, right and root. Now let's talk about how an expression tree is evaluated. We do not evaluate it randomly. We always use something called postorder traversal. Why postorder? Because in mathematics we must calculate values before applying operators. So first we solve the smallest part in expression. In this example we start with 2 plus 3, which gives us 5. Only after that we apply the multiplication with 4. So finally 5 multiplied by 4 gives us 20. This is why post-order traversal is the best and correct way to evaluate an expression tree. Before we finish, let me quickly tell you some common mistakes students make. Some students place operands as parent nodes. Some ignore the brackets, and some try to evaluate using inorder traversal. All of these are incorrect. Alright, let's quick summarize what we learned today. First of all, an expression tree is a binary tree. That means each node can have most 2 children, a left child and a right child. Next, in an expression tree, operators are always stored in the internal nodes. These are the nodes that connect other nodes and represent operations like plus, minus, multiply and divide. Then operands are stored in the leaf nodes. Leaf nodes do not have any children and they represent values like numbers or variables. Finally, and this is very important to remember, post-order traversal is used to evaluate an expression tree. In post-order, we process the left child first, then the right child, and only then the root, which allows the expression to be evaluated correctly. If you remember these 4 points, you can easily understand and answer any question related to expression trees. And that's all for today. I hope you have a clear understanding about expression trees. If you enjoyed this video, don't forget to like, share and subscribe for more lessons on data structures and algorithms. See you in the next one. Bye for now.